Hello everyone, welcome to my channel Chemistry by ANR. Today's topic is of hydrocarbons, and hydrocarbons are compounds containing carbon and hydrogen only. They can be saturated, unsaturated and aromatic hydrocarbons. Among saturated hydrocarbon we have alkanes containing all sigma bond, no pi bond. And amongst unsaturated, we have alkenes and alkynes. So let us see the topics one by one. Now, over here, alkanes have the general molecular formula CnH2n plus 2. That's the general molecular formula of alkane, and the simplest alkane is methane, having carbon number equal to 1. So we can say CH4. So hence that's a molecular formula CH4 for methane. If N is equal to 2, then it is C2H6, that is ethane. Now over here we can see the structure of methane. The carbon atom is sp3 hybridized with a bond angle of 109.5 degree. These all things we know as per the knowledge from chemical bonding chapter, and it has a tetrahedral structure, and here it has 4 bond pairs and 0 lone pairs. Next, moving on to this part, we can see nomenclature and isomerism. Here one example is given, C4H10. Now, if I say C4H10, 4 carbon atoms are there and it is an alkane. Why? Because it fits into the formula CnH2n plus 2. Because it is C4n is equal to 4, 4 2s are 8 plus 2, 10. So now if 4 carbon atoms are written in a straight chain, then it can be like this, C1, 2, 3, 4, 4 carbon atoms in a chain. And this is normal butane, N-butane. So having a boiling point which is 273 Kelvin. Now we can see 3 carbon atoms in a chain we can keep, and the 4th one we can keep as a branching. This is 4th one which is kept as a branching, and so this is the substituent, because this is your main chain. This is your main chain. So the substituent is methyl and it is in carbon number 2. So 2-methyl propane. This is also known as isolinkage, because always remember isolinkage is CH3, CH, CH3. This part is known as isolinkage. If you note, see the boiling point over here for normal chain is 273. When there is a branching, the boiling point decreases. The boiling point decreases on account of decrease in the surface area. So with increase in branching in the structure, when the branching increases, the surface area of the molecule decreases, and the van der Waals interaction. Why I am telling van der Waals? Because alkanes are non-polar in nature. The van der Waals interaction decreases, the boiling point also decreases. So they are related to each other. Now, after this, talk about pentane, C5H12. Pentane, we can write 5 carbon atoms in a straight chain like this. So it is the normal pentane, N-pentane, having a boiling point of 309 Kelvin. And if I form a branching, I can keep 4 carbon atoms in a chain with a methyl as the branching. Now, if I keep it in this carbon, then also it is carbon number 2, because I am numbering it from left to right. Now, if I shift the position and I write CH3, CH2, then CH, a CH3 over here and a CH3 over here, then this is also 2 position having methyl. So 2-methyl butane or isopentane. Isolinkage, I have already told you what is isolinkage, having this type of part. This is known as isolinkage. So having this part is known as isolinkage. Now here after this, why is it isopentane and not isobutane? Because you have to count the total number of carbon atoms present in the compound. So it is isolinkage, but it is an isolinkage of a pentane system. So isopentane. If you note, The boiling point decreases from 309 to 301 Kelvin because there is branching occurring, and so with increase in branching the surface area again decreases and boiling point decreases. Now here we can see two types of isomers. Another one, see for the pentane, you reduce the number of carbon atom. Previously you have kept 4, now you keep 3 carbon atom, and the third, and this is the fourth one and this is the fifth one. So fourth and fifth can be kept as a branching like this: 1, 2, 3, 4 and 5. So when you number it, obviously you have to number it 1, 2, 3, or you number it 1, 2, 3. It's the same thing. 2 position, it has 2 methyl group if you give the hydrogen. So it is 2, 2 dimethyl propane system, but it is a neo system because this carbon atom is actually attached to a neo system. 2 branching are there. So it is a neo system with total 5 number of carbon atoms, so neopentane. And when the branching again increases from an iso to neo, see the boiling point is decreasing even more. So these difference in the structures of the same pentane, they are what? They are isomers. Why? Because they are having same molecular formula, they belong to pentane, but their structures are different. So they are structural isomer. Now, whether they are chain isomer or not, these structural isomer, only the difference is in the chain structure, the main chain structure. So they are known as chain isomers. Either it is a straight chain or it is a branched chain. So based on this, we can see this example, problem 9.1. Write the structures of different chain isomers of C6H14. So this is known as hexane system. So in hexane, just the way you have done in pentane, the same way you have to proceed. Like first keep 6 carbon atoms in a straight chain, so it becomes N-hexane. Then keep 5 carbon atoms in a straight chain, give 1 branching. Then change the position of the branching, once in 2, next in 3 position. Then what you can do, you can keep 1, 2, 3, 4 carbon atoms in a chain. So you can keep 5th and 6th in different branching or in the same branching. So these are the possible ways how you can write the structures and write the IUPAC names following the norms. This was another of neopentane, that is the same thing we can see. Now, moving on to the other, this is write structures of different isomeric alkyl groups corresponding to the molecular formula C5H11. Okay, C5H11. That means this is an alkyl group. And this alkyl group is known as pentyl group. When it is as pentyl, what you can do? You can attach this OH as per the question into different position. So when you do it in carbon number 1, it is pentan 1 all. Shift the position to carbon number 2. So when you number it like this, this is pentan 2 all. Shift it to 3, pentan 3 all. So this is like this. Now here you can see this is the example where you are starting to number it from the lowest side of the functional group. So 1, 2, 3 and 4, 2 position there is a methyl and functional group is all. So 2 methyl, 1, 2, 3, 4. But system, butanol या फिर butan 1 all. This one you can see keeping 1, 2, 3, 4 carbon atoms in a chain. This is your 5th carbon and OH on the 2nd position. So obviously branching is there with a functional group at position 2 and CH3 at position 2. So 2 methyl. First the substituent, 2 methyl butan 2 all. Write it in a straight line always in your exam. This one numbering will be from the side of the functional group. So this becomes 2, 2 dimethyl propan 1 all or propanol. This one again, see you can number it from left to right, then the position of the functional group will not be minimum. So obviously you have to number it from right to left. So you are numbering it in this manner. 3 position there is methyl. So 3 methyl butan 2 all. Next, this one. These are certain examples where the numbering is being seen, how the lowest sum and alphabetical arrangement is being seen. So the branching also should be given in the lowest position. When you number it in this manner, it is 4-ethyl. E comes first. So you can number it 1, 2. So 2 plus 4 is equal to 6. Why? 2 position there is a methyl, 4 position there is ethyl. So sum up the position as per lowest locant rule. If you would have numbered it 1, 2, 3, 4, 5 and 6, the number would have been 3 plus 5, which is equal to 8. You have to follow the lowest numbering. So lowest locant rule is this. This thing is only being done here. So these examples you have to see very, very minutely. Now write IUPAC names of the following compounds. Same thing, you need to draw the structure, please. That means for this you open up the structure. Suppose this one I am showing you. So this will be CH3 whole thrice. So you are writing a CH3. You are writing C here. So suppose this is, you are writing CH3 and you are writing C. This is another CH3, this is another CH3, CH3 whole thrice C. Then you are giving CH2, then you are writing C, again giving CH3, CH3 and a CH3. And the numbering will be what? Numbering will be 1, 2, 3, 4, 5, either this. Now you see what it happens. If you do this, then the lowest locant rule will say, yes, you have 2 plus 2 for 2-methyl. You have 4 plus 4 for again 2-methyl. And this is it. Okay. So if you number it 1, 2, 3, 4, it's the same thing. 2 position or 4 position. So any way you number, this is like this. Now, tetra, tertiary butyl methane. So this is tetra means 4. Tertiary butyl methane. That means methane is CH4. So here there are 3 tertiary butyl, 4 tertiary butyl groups, because tetra means 4. Tertiary butyl, that means the carbon atom which is attached is tertiary. That means it is attached to 3 more carbon atoms and total having 4 carbon atoms. So butyl. So again here 1, 2, 3. This is also 1, 2, 3. Then only it is tertiary. Don't count this carbon, leaving this carbon. So 1, 2 and 3. This is tertiary butyl. Fill up with hydrogen and then you will see it is like this. Ditertiary butyl 2,2, 4,4 tetramethyl pentane. So this is how you have to do. That means give the find the longest carbon chain, give lesser number to the substituent, lesser number to the functional group, and see which way of numbering is feasible. So in the next module, we are going to deal with preparation of alkanes. Till then, bye all of you.